In the third problem, we're told of a sphere that is conducting, and it's isolated. We're told about its charge, and we're told to find in part A the potential energy stored. And the potential energy stored for a capacitor is given by the charge on the capacitor divided by twice the capacitance. And for a sphere, the capacitance can be given as 4 pi epsilon naught times the radius of the sphere. So this gives us that the potential energy is q squared over 8 pi epsilon naught r. And now if we plug in these values, we have 1.25 times 10 to the minus 9th Coulomb quantity squared over 8 pi epsilon naught is 8.85 times 10 to the negative 12th. And one of the ways you can represent this is as a farad per meter times the radius, which is given as 0.0685 meters. If we multiply this, we get about 1.03 times 10 to the minus 7th joules. In part B, we're asked for the energy density for the surface of the sphere, and the energy density mu is 1/2 epsilon naught times the square of the electric field. And if you recall that the electric field for a sphere was given by the charge over 4 pi epsilon naught, we normally wrote this as k on the top, but since we have an epsilon naught in the equation, we might as well leave things as epsilon naughts divided by the radius squared. So now this means that mu now equals 1/2 epsilon naught, and instead of E we're going to put q over 4 pi epsilon naught r squared, the whole thing squared. And you notice that this leaves us with q squared on top. We get 4 squared times 2, which is 32 pi squared. We get epsilon squared here, and one of them cancel, but we still have an epsilon left over, and then r squared is r to the 4th. Applying these values now, we have 1.25 10 to the minus 9th Coulomb squared, 32 pi squared times 8.85 10 to the minus 12th. Since we're looking for units of electric density and energy density, we can rewrite this in terms of Coulomb squared per Newton meter squared times the radius, which is 0.0685 meters quantity to the 4th. Do these calculations, and you should get about 2.54 times 10 to the minus 5th joule per meter.